Alright, so today we're going to be talking about Chapter 6, Lesson 3. This is called Solving Equations with Rational Coefficients. So when we go ahead and start looking at rational coefficients, this is going to be the key word that we're going to be looking at here. Rational, again, if you remember from Chapter 4, means a number that can be written as a fraction. So, for example, a decimal can be written as a fraction. So let's say we have like 0.1 or 3.75. Or maybe 0.6, negative 0.6, or maybe, let's say we even have 4.1 repeating. Now, as far as fractions go, we can do 1/10, we can do 3/4, we have 3/5 we could do, make it negative maybe even, negative 1/9. Those are good examples of fractions where we have a number in the numerator and one in the denominator. Now, the last one that we're going to be talking about is mixed numbers. So we could do 2 and 1/10, or negative 3 and 3/4, or 7 and 3/5, negative 4 and 1/9. So the difference between a mixed number and a fraction is a mixed number has this right here. It has an integer in front of the fraction, which really means that we have, for example, in this first one here, we have 2 wholes and 1 out of 10 pieces to make a third whole. In this second fraction, we have 3 wholes and 3 out of 4 pieces needed for another one. Now, when we go through this, there are going to be some times where we have decimal coefficients. For example, in example 1. There are going to be some times when we have fractions or mixed numbers. And I'm going to show you the way that we would have done it in Chapter 4 with complex fractions. And then I'm going to show you a little bit of a shortcut. But first of all, let's look at example 1. Solve 10 equals 0.5x. Now, as we solve equations, it's nice to draw a line right through the equal sign so we can stay balanced. Now, over on the right side here, we have 0.5 times x. Let's turn that on to make things a little bit easier for us. So we have 0.5x, that way we don't have any notifications. Now, this is 0.5 times x. Notice how the x here is a variable, it's not multiplication. So when we go ahead and do this, this is really 0.5 times the variable x. Now, to undo this multiplication, we have to divide. When we divide, if you recall from our multiplication and division equations lesson with lesson 2, we make it look as if we are making a fraction. Because now this fraction, 0.5x over 0.5, simplifies to just x. And if I do the same on the right side, be careful now, because we have a 0.5 instead of just a regular 5. So you want to do 2, but the answer to this question is really 20. And if we go back and check, 0.5 times the 20 would be 10. Alright, let's look at example 2 now. So example 2 says to solve 2/3 x equals 6/15. Again, I'm going to draw a line. Now, again, this is 2/3 times x, so I'm going to make a complex fraction because I'm dividing by 2/3. And this entire fraction over here, this entire fraction, will result in just x. Now, the issue is going to come in over here, because this is not going to simplify very nicely. But the good thing is we know how to do this. So 6/15 over 2/3, if you recall, really means 6/15 divided by 2/3. And when we are dividing fractions, our method was to keep the first fraction, change division to multiplication, and flip the second fraction to become its reciprocal, which literally means to flip over. And now we're multiplying. So when we multiply fractions, we're going to multiply the numerators, multiply the denominators, and simplify. So 6 times 3 is 18, 15 times 2 is 30. Now there is a common factor here. Both 18 and 30 can be divided by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So now we can come all the way back over here and say that x is 3/5. So now if we look, that's a lot of work to solve one problem. There's a quicker way, and that quicker way means that we get to this step here first. So let me show you that with example 3 here. We have the same problem essentially, the only difference is instead of 2/3 it's negative 2/3, and instead of 6/15 we now have 12. But same exact process, draw a line through the middle. Now, we talked about how dividing by a fraction really means multiplying by its reciprocal. So I'm going to, instead of divide, I'm going to multiply by the reciprocal. I'm going to turn 12 into a fraction and do the same thing. Again, this right here, when I multiply a fraction by its reciprocal, the answer will always simplify to 1. So 1 times x results in x. Same process, or same answer by a different process. Now, on the right side here, I don't have to worry about the division process because it's already in multiplication. So this numerator now would be 12 times 3, and the denominator would be 1 times negative 2. 12 times 3 is 36. 1 times negative 2 is negative 2, and that simplifies to negative 18. Alright, example 4 then. We now have a mixed number as our coefficient. So if you recall, a mixed number talks about this number here being the number of wholes, that number there being parts to make a whole, and this number here being just the parts. So if I go through this then, let's erase this then. So if it takes 8 pieces to make a whole, and I have 4 entire wholes, I'm going to do 4 times 32, or sorry, 4 times 8, to get 32, which means in this 4 wholes, there are 32 pieces. Plus, I have this 5 extra pieces, so really this is 37/8 over x equals 74. Now, using my process from before, we're going to draw a line down the middle, and we're going to multiply, I'm going to get rid of this, by the reciprocal. And of course, if it happens on one side, it has to show up on the other. This right here simplifies to just 1, so I have x left over. This right side now becomes a little bit tricky if we don't do our cross cancellation. So what we can do is look in this direction here. So I'm going to go like that. 74 and 37, they have a common factor. In fact, the common factor is 37. So I'm going to take away a 37 from each of those. I can take one 37 out of 37. And I can take two 37s out of 74. So now my new multiplication problem is 2 over 1 times 8 over 1, which happens to be 16. And then our last problem, this is a word problem. So it says Samantha answered 4/5 of the questions on her science test correctly. If she answered 8 questions correctly, how many questions were on the test? So, she answered 4/5, and that was 8 correctly. We want to know how many questions were on the quiz. So let's make a variable. Let's say that Q is questions on quiz. Now, she answered 4/5 of the questions on the quiz correctly. So I'm going to start writing this equation. 4/5 of Q. That is 8. So now we have to solve to figure out how many questions are on the quiz. So that would be this Q here. So as I go through this now, I have a fraction. In order to get this by itself, I have to divide. But when I divide by a fraction, it really means I'm multiplying by its reciprocal. And change that into a 1. Make a line. Again, this right here simplifies to 1, so all I'm left with is Q. On the right side, I have a little bit more work. 8 times 5 would be 40. 1 times 4 is 4. And this simplifies down to 10. You could have also done it a little bit different, just like what we did on this problem up here, where we did a cross cancellation. You do the same thing here, because 8 and 4 have a common factor of 4. So if I take a 4 out of each of those, I can take 1 4 out of 4 and 2 4s out of 8. So now my new problem would be 2 over 1 times 5 over 1, which happens to be the 10. Alright, that is the end of